This is eDevice tutorial 10. I'll be going through two questions here, question 3 as well as question 4. In this question 3 here, we are given a 741 op-amp with the following parameters. Vs is plus minus 12 volts, the saturation voltage is plus minus 10 volts, and the slew rate is 0.5 volts per microseconds. So if the 741 op-amp circuit is designed to have a voltage gain of 50, right? Whether it is possible, right, for it to amplify without distortion an input sine wave of amplitude 0.2 volts peak to peak. The frequency of the sine wave is given as 20 kilohertz, and then we must verify our answer here with the calculations. So what I will do is actually I will just start off by drawing a box here. Okay, so this box here represents the op-amp, 741 op-amp circuit. Okay, and inside this box here we gather all the information that is actually given to us here. Okay, so we must gather things like the slew rate, right? So the slew rate is given here as 0.5 volts per microseconds. Okay, we are also given the voltage gain as 50. Okay, so these two parameters here belongs to the op-amp circuit. Okay, then on the left side here, this is actually our input side. Okay, so we have information about this also given in the questions. So this is actually the V in, right? The V in is given as a sine wave, okay, with amplitude of 0.2 volts peak to peak. Okay, so that means we have this, okay, 0.2 volts peak to peak, a sine wave. Okay, and then for the output side here, okay, there's no information at all. Okay, we are also given a sine wave frequency of 20 kilohertz. Okay, so the next step here is actually to find out what is the Vout first. Okay, so to find out what is the Vout of this amplifier system here, right, we use the simplest formula for voltage gain, which is just Vout over Vin. Okay, and then we rearrange this to give Vout. Okay, so Vout will then be equals to AV times Vin. Okay, the voltage given in the question itself is 50, right? The Vin is 0.2 volts peak to peak sine wave, so we just simply multiply it with the value. Okay, so the value for Vout will then be equals to 10 volts peak to peak. Okay, now from here we will then calculate what is the output voltage peak value. Okay, so it's half of 10 volts peak to peak. Okay, and that will be equals to 5 volts peak. Okay, so we are going to make use of this value of 5 volts peak here, right, to use inside the equation for SR, okay, the slew rate. So this is based on the sine wave, so the SR sine wave formula, right, will be equals to 2 pi Vout peak multiplied by the maximum frequency. Okay, so our motive here is to find this maximum frequency, right, so that we can then compare with the frequency that is being pumped into the system, which is 20 kilohertz. Okay, so we can rearrange the equation to give for F max, right? So F max is just equals to the SR sine wave value, right, divided by 2 pi multiplied by the output peak voltage. Okay, so I'll just substitute the values now. So the SR sine wave is given as 0.5 volts per microseconds. Okay, so it's actually 0.5 volts over 1 times 10 to the power minus 6 seconds. Okay, so this will then be divided by 2 pi multiplied with the output peak voltage, which is 5 volts peak. Okay, if you calculate this out, the maximum frequency will then be equals to 15.92 kilohertz. Okay, so we can then conclude that since the input frequency, which is 20 kilohertz, as given by the question, is actually greater than the maximum frequency that this amplifier system can actually sustain up to, right, 15.92 kilohertz. Okay, so hence there will be distortion. Okay, at the output. I'll move on now to question 4. So in this question 4 here, we are to refer to the circuit diagram in figure Q4. It's given that the open loop voltage gain, or AOL, of this op-amp here is 100,000 volts per volts, and its saturation voltage V saturation is being equal to plus minus 9 volts here. The forward voltage of each LED, right, in this circuit here is given as 2.4 volts. When the variable resistor R port is adjusted to 6K, that means the value of this R port here is 6 kilo ohms. Right, the first thing that we are asked to ask is to determine the voltage at point A, VA. Okay, so that means it's at this point here, we are supposed to find out what is VA. Okay, notice that we have over here, right, a circuit, and VA happens to be in between, okay, the two resistors R1 and R port here. So to find out what is VA, right, notice that the voltage at point A, VA, is also the voltage across the R port variable resistor. Okay, so by voltage divider rule, therefore this VA here is actually R port over R1 plus R port multiplied by 10 volts. Okay, so we will have a value of 6 kilo ohms over 4K plus 6 kilo ohms times 10 volts. Okay, so then this will give us a value of 6 volts for VA. To part B, right, determine what is the voltage at point B here. Okay, so this is point B, VB, right. Notice that this point B here, right, is actually the output of this op-amp. Okay, and if you realize, right, this op-amp is actually open loop op-amp. Okay, so it is a comparator. Okay, so since it's a comparator, right, therefore the output at this op-amp here, VB, right, will have this formula, which is AOL times V plus minus V minus. Okay, the V plus in this case refers to VA, right? The V minus here refers to VS. Okay, so AOL is given as 100,000. This is then multiplied with VA minus VS. So VA, we have calculated this earlier, so it's equals to 6 volts minus VS. So VS is given as 5 volts. Okay, and therefore the initial value of VB is actually plus 100,000 volts. Okay, now this output value here at the output terminal of the op-amp is very large at 100,000 volts. Okay, we are also given the saturation voltage of this op-amp being equals to plus minus 9 volts here. Okay, so therefore we can make this comparison here, since the magnitude of VB, right, is greater than the positive value of plus V set. Okay, so therefore VB will then be equals to plus V set, which is equals to plus 9 volts. Okay, so therefore VB here is plus 9 volts. Okay, then we go on to part C. Right, part C is to state which LED will be forward bias and light up. Okay, so as you can see, the output voltage at the op-amp is 9 volts, positive 9 volts. Okay, so therefore current will actually be flowing through LED 2. Okay, LED 1 will be actually blocking the current, okay, from the output terminal of the op-amp. So therefore LED 2 will be forward bias and light up. On to part D, right? Determine the output voltage V out. Okay, so this is the output voltage here, V out, with respect to ground. So with respect to ground, so that means V out, right, covers the voltage across LED 2, which is forward bias, and therefore V out will be equals to the voltage across LED2. Since LED2 is forward biased, therefore the voltage of Vout will then be equals to 2.4 volts. And that's for tutorial 10.